Morning, students. In the last session we have discussed about the different type of synthesis of nanomaterial by different methods. So in our topic, which is our next topic, which is related to characterization techniques in the fourth module. What is the need of characterization for the materials? So if we are going to prepare a nanomaterial, we have to characterize those nanomaterial by using different techniques. So characterization is nothing but to find the strength in the material, to find the different properties of the materials, to find the microstructure, to find the molecular mass, or else to find the morphology. To find out these, we want the characterization techniques. So when we talk about the different type of polymers, or it may be the nanomaterial, after synthesis of the polymers or it may be the nanomaterials, we go for the characterization. To see the properties of those materials, we prefer the different type of the characterization techniques. So what else we are going to test here? So characterization is nothing but we are going for the finding out of the molecular mass, or it may be the molecular structure, even when we prefer polymers. In the same way, when we go for a nanomaterial, we go with morphology, or else mechanical properties and thermal properties. So here when we talk about the polymers, or it may be the films, or it may be the nanomaterial, we go for characterization by using the molecular mass, or the molecular structure, or the morphology, or it may be the mechanical properties, or it may be the thermal properties. So to characterize, to find out these properties, we go with the different techniques that we call it as the characterization techniques. That is, we call it as a characterization techniques. So what is the objective of these? When we go through all these topics related to the characterization techniques, we should come to know what to mean by polymer characterization. So when we prefer polymers, it is related to polymer characterization. If we prefer the materials, nanomaterial, that is with respect to nanomaterial characterization. If we prefer a polymers, we find the molecular mass, or it may be the molecular structure. So in the same way, when we go with respect to the nanomaterial, we go for finding out the morphology of that one, or else the mechanical properties. It may be any of the properties related to mechanical, or it may be the related to thermal properties. So now when we go with respect to the polymers, or it may be the nanomaterials, so we go by these, and we should come to know after detailed discussion of all these topics. So now we start with the first topic, which is polymer characterization. So when we prefer a polymers, what we mean by polymer characterization? So a polymer, in a Greek word, we call it as a poly means many, and in the same way mers mean parts. So many parts, that is larger molecules or macromolecules composed of many repeated subunits, that we call it as a polymer here. So polymer is nothing but many that is many monomers or many parts. So many monomers or molecules, when it comes together to form the polymer here. So repetitive subunits, that is the monomers, number of monomers or the number of molecules form together to form the polymer here. So polymer characterization is it is a branch of the polymer science, analytical branch of the polymer science, which concerned with the characterization of polymeric materials on a variety of levels. So the characterization typically has a goal to improve the performance of the material. So why we go for characterization is to go for the improvement or to increase the properties, increase the performance of the material. So characterization techniques are typically used to determine the molecular mass, molecular structure, morphology, or it may be the thermal properties, or it may be the mechanical properties. To find out this, we go for characterization. So characterization technique should ideally be linked to the desirable properties of the material. So it may be related to the mechanical properties, or it may be related to the thermal properties. We go by these, that is a strength, or it may be the impermeability, thermal stability, optical properties. So we prefer these different properties, desirable properties. With respect to this, we go by the mechanical as well as the thermal properties. The four components of the discipline of engineering material and their interrelationship. So what this figure indicates. So here we are having the processing, structure, properties, and performance. So when by this figure we come to know that when we synthesize the nanomaterials, synthesizing the nanomaterial plays a very important role here. So the performance, any of the material performance depends upon the properties. So the properties which depends upon the structure, and structure which depends upon the processing. So processing is nothing but the manufacturing or synthesizing of the material here. So the material, it may be the nanomaterial, or it may be the polymers, or it may be any of the material. So when we are going to process any of the material, process plays a very important role. When we go for a synthesizing of nanomaterial, by different technique is a very important process here. So processing plays a very important role to get the required structure. So if we get the required structure, if we get the required nanoparticles, if we get the required size of the nanoparticle, if we get the uniformity of the nanoparticles, so then only we get the uniform structure in the material. So if we get the uniform structure or the required structure in the material, then we get the required properties. So if the properties are of a required one, then the performance will be the ultimate here. So the performance which depends upon the properties which depends upon the structure, and the structure which depends upon the processing here. So before going to synthesize any of the material, we have to take care of the process for synthesis here. So by we are having a different techniques in synthesizing of the nanomaterials. So the which method we have to adopt for which material. So what is the end material? So what should be the end application? So based on the end application, based on the end the properties, we have to choose the accurate synthesis process here. So processing plays a very important role in the synthesis of nanomaterials here. So that is what this figure which illustrates here. So what do you mean by molecular mass? So molecular mass of a polymer differs from typical molecules here. So polymerization reaction produces a distribution of molecular weight and shape. So the distribution of molecular masses can be summarized by the number average molecular weight. When we are going to find out the molecular mass, we prefer the different ways. By different methods, we go for finding out the molecular mass here. So number average molecular weight, or weight average molecular weight, or else when we go for determining these the molecular mass by the number average molecular weight, or weight average molecular weight, at that time we go by these properties, that is the colligative property measurements, or it may be the static light scattering techniques, viscometry, size exclusion, chromatography. So whatever right now I am explaining, these all these are only the out of syllabus, but you should know these before going for the actual characterization techniques. So why we go for optical microscope, or it may be the scanning electron microscope, transition electron microscope, like this we are having different techniques. So what all the techniques we study, where we are going to apply these. So because of this I am going to explain this topic. The topic whatever I am explaining here, this is the out of the syllabus of you, but you should know this topic before going to the actual topic here. So because of that I have taken this topic. So why we have to use different techniques, where we have to use different techniques, that is because of that I have taken this the topic today to discuss here. So the size exclusion chromatography, these all are the methods parameters which we are going to use for determining of the molecular mass. So we are having here one of the method, that is a gel permeation chromatography. So this method which is used for the finding out the molecular mass. So that is what we call it as chromatography. Chromatography is one of the technique which is used to find the molecular mass here. So technique used directly to determine the molecular weight distribution parameters. So to find out the molecular weight distribution, we use the gel permeation chromatography technique here. So based on the polymer's hydrodynamic volume, that is based on the hydrodynamic volume and the radius of gyration, based on this process works here. So based on this hydrodynamic volume and radiation of gyration, gel permeation chromatography technique works here. So the material which we use here is the silica or rigid porous gel material which is used, and the stationary material will be glass beads here. So larger molecules moves faster than smaller molecules here. So based on this, we go for the classification of the nanomaterials. So in this we are going to use a gel material, and the glass beads we are going to use. So by the hydrodynamic volume and radius of gyration, the material goes for filtration here. So based on this, the larger molecules move faster than the smaller molecules here. So that is what we are having. So larger molecules will settle there only, whereas smaller molecules will go for filter. Like this, we go for finding the molecular mass or the molecular weight distribution by this gel permeation chromatography technique here. So in the same way, we are having the gas chromatography technique, which is based on the volatility and polarity of the material. So based on this volatility and polarity of material, gas chromatography works here. So in the same way, we are having mass spectroscopy. So based on the size of the molecules, mass spectrography works here. So we are having heating zone, ionizing, deflection, detection zones. So rotating fan with a ball here. So that is what we are having, rotating fan with a ball. So when we are going to have a rotation of this fan with respect to a ball, what happens here is the large molecules, that is larger molecules, will have less deflection, whereas smaller molecules will have more deflection. So when we go for rotating, when the fan rotates faster here, the smaller molecules, smaller balls will have more deflection, whereas the larger balls will have less deflection here. That is what we are having with respect to mass spectroscopy. When we are having a larger molecules which will have less deflection, when we are having a smaller molecules, there will be have more deflection here. Based on that, we go for the finding out of the molecular mass of the material here. So we are having a schematic diagram for that. We are having heating zone, ionizing zone, deflection. Like this, we are having the different zones for the device. Based on by this device, we go for finding out the molecular mass. That is what the technique it is having with respect to the mass spectroscopy. So molecular structure, how to find the molecular structure here. So many of the analytical techniques used to determine the molecular structure of unknown organic compounds are also used in polymer characterization here. So when we want to find a molecular structure, so at that time we go by these spectroscopy techniques. So we are having X-ray diffraction, we are having ultraviolet visual spectroscopy, infrared spectroscopy, nuclear magnetic resonance spectroscopy. So these all are the techniques which are used to find the molecular structure of the material here. So for our syllabus, we are having X-ray diffraction technique. So we will discuss about the X-ray diffraction techniques when we go in detail of the different types of the techniques. Okay. So now, on what basis all these process depends upon X-ray diffraction, ultraviolet visual spectroscopy, infrared spectroscopy, or it may be the NMR scan. All these depends on this criteria here. So based on its that is the frequency or the wavelength, based on its wavelength, as well as based on the technique how it works here. So X-ray, which is having 0.01 to 10 nanometer, which is having ultraviolet rays which is having 10 to 400 nanometer, visual spectroscopy which is having 390 to 750, that is infrared radiation, that is near infrared or infrared radiation which is having 750 to 1 mm we are having, microwave which is 1 mm to 1 meter it is having. So these all works based on the movement of inner electrons, outer electrons, or molecular vibration or molecular rotation. Based on these process works here. So here we can see here based on when we see the X-ray, when we see the ultraviolet or infrared, microwave, radio wave frequencies, all these depends upon the frequency, its energy, and its wavelength. So the X-ray technique, what we are having, this X-ray technique is having high frequency, high energy with short wavelength it is having, that is 200 nanometer, which is a short wavelength which is having here, and ultraviolet which is having high frequency, high energy, but a short frequency which is having, that is a 400 nanometer. So in the same way we are having the infrared rays. So infrared rays which is having a high energy, that is high frequency, as well as the short wavelength which is having. So in the same way microwave, radio waves, and the that is the nuclear magnetic resonance, all these are having low frequency, low energy, but high long wavelengths it is having. So because of this, the radio waves are used for different techniques, for different applications. Microwaves are used for different applications, whereas X-rays are used for different application. Ultraviolet rays are used for different application here. So when we see X-ray, ultraviolet rays, these rays are having high frequency, high energy, but shorter. That is, the distance of movement of these rays will be how shorter wavelength here, whereas microwave, radio wave frequency, whatever we are having, this is having a movement of this wavelength is longer here, whereas the energy as well as frequency is less in this case. So that is what we see with respect to different techniques here. So based on the X-ray technique, based on ultraviolet, or based on infrared rays, we go for different techniques which we are going to use here. So that we should know why we use X-rays in those applications, or ultraviolet rays, or infrared rays, microwaves, which applications we are going to use. Based on these we have to see. So in the same way we are having morphology. What do you mean by morphology? We go for characterization of morphology with respect to the materials here. So what do you mean by morphology? So it may be the polymer, or it may be the any of the nanomaterials, or it may be the alloys, whichever it may be. When we go for the characterization of the morphology, it is a micro scale property that is largely dictated by the amorphous or crystalline portion of the polymer chain and their influence on each other. So when we go for studying of the morphology, we see the property with respect to the amorphous, or it may be the crystalline, or when we take an example of alloy, the distribution of alloy with respect to other alloy. In an alloy, the metals are distributed equally in all the spaces, or the metals which have been soluble in the material. So all these are being studied by using the morphology. So when we take an example of iron carbon diagram, so in iron carbon diagram, that is carbon material is deposited at one of the area, or the carbon is been entirely spread over the material. So to find out this, we go for studying of the morphology here. So that is what we call it as the material which is amorphous, or it may be the crystalline, or it may be the material where we see the distribution of the material. So those all are being studied by using the morphology here. So microscopy techniques are especially useful in determining these micro scale properties. So when we are having a micro level, when we are having a nano level, so at that time we prefer the scanning electron microscope, or the optical microscope, which are not used for the micro level. Micro level we can use, whereas when we go for a nano levels, we cannot use microscopy techniques by using scanning electron, or it may be the transmission electron microscope are used for the studying of the micro scale properties, which creates the polymer morphology large enough to be viewed using modern microscopy instruments. So these all are the modern instruments, microscopy instruments what we are having. By this we can go for the visualizing or studying of morphology of the materials. So the common microscopy techniques which we use for the morphology study is the optical microscope. The optical microscope which is used, scanning electron microscope, transmission electron microscope, or it may be the atomic force microscope. So these all are the microscopic techniques which are used for the morphology study. So these all are with respect to our syllabus. So in our syllabus we are going to study about the optical microscope, scanning electron microscope, transmission, atomic force with respect to its working principle as well as application, advantages and disadvantages. This is the actual syllabus what we are having with respect to the model 4 with respect to the characterization techniques. So in the same way we go for characterization of thermal properties by using thermal analysis. So we have till right now we have studied or discussed about the mechanical properties. So how to find out the mechanical properties? We can find the strength, we can find the elastic or modulus properties, we can find the morphology. So like this we find the mechanical properties. In the same way we can find the thermal analysis, that is thermal properties can be analyzed by using differential scanning calorimetry. So by using differential scanning calorimetry we can find the properties with respect to thermal. So in the same way thermogravimetric analysis is used. Dynamic mechanical analysis, here with respect to the change in its temperature and time, with respect to this we can find a dynamic mechanical analysis. So thermal as well as mechanical, both the properties can be analyzed by using dynamic mechanical analysis process. So thermomechanical, so which is what we have seen, the dynamic, it is with respect to the time, that is dynamic, whereas thermomechanical with respect to temperature, the increase or decrease in temperature. With respect to the mechanical properties we can find out the properties, we can find out the characteristics, that is thermomechanical analysis. So these all are with respect to the thermal, and the last two what we are seeing, it is with respect to thermomechanical. Both the thermal as well as mechanical, both the properties can be analyzed by using these techniques. So these all are the different techniques what we are having. So these polymer characterization, which is with respect to thermal analysis, particularly differential scanning calorimetry can be used. So compositional and structural properties of the material usually affects its melting temperature or gas transition temperature, and this in turn can be linked to many performance parameters. So semi-crystalline polymers, it is an important method to measure crystallinity. So it is an amorphous or it is a crystalline that can be analyzed by using the differential scanning calorimetry. So thermogravimetric analysis can also give an indication of polymer thermal stability and the effect of additives such as flame retardants. So based on the by using this differential scanning calorimetry we can find the flame retardants or the effect of additives can be found out here. So for this we use by using gravimetric analysis we can find the thermal stability, what is in thermal stability, as well as what are the additives. When we add an additives, what is an stability of it, as well as flame retardants. Flame retardants can be found out by using thermogravimetric analysis techniques here. So thermal analysis techniques are typically combination techniques we are having, that is what with respect to dynamic mechanical thermal analysis. So when we talk about differential scanning, in the same way we are having differential thermal analysis, thermomechanical analysis, dynamic mechanical thermal analysis, dielectric thermal analysis. So these all are the different techniques when we go with respect to thermal analysis. So when we talk about the mechanical properties, so characterization of the mechanical properties or a polymer typically refers to the measure of its strength of the polymer film, or it may be the nanomaterials here. So tensile strength or its Young's modulus of elasticity or of a particular interest for describing the stress strength properties of polymer films, or it may be the nanomaterials. So dynamic mechanical analysis is the most common technique used to characterize viscoelastic behavior. So when we want to find out the viscoelastic behavior of a material, we prefer the dynamic mechanical analysis here. So we are having other techniques can be find out by using these techniques. The properties can be find out, that is by using the viscometry, or it may be the rheometry or pendulum hardness. All these are other techniques which can be used to find out the other properties. So for our syllabus we are having optical microscope. The first technique what we are having is of optical microscope. So all of you have studied the optical microscope. So optical microscope, which is used for the it is a type of microscope which uses visible light, and a system of lenses to magnify images of small samples. So when we are having a small sample, this can be magnified, as well as by using the lenses. By using lenses we can go for the magnifying, and we can see by using visible rays or the visible light. So that is what we are having, optical microscope. So it is a simple type of the optical microscope which is used for a different application purpose, for the imaging or for the viewing of the different properties. So here optical microscope often refers to a light, that is a light microscope. We call it as a light microscope. It is a type of microscope which uses visible light and a system of lenses to magnify images of a small samples here. So optical microscope are the oldest design of microscope, and were possibly invented in their present compound form in the 17th century. It has been invented in 17th century. Optical microscope can be very simple, although there are many complex designs which aims to improve the resolution and sample contrast here. So this microscope depends upon the magnification and the resolution. So what about the magnification? What about the resolution? So the magnifying, that is the magnifying which ranges from the 100 to 2000, 3000x. So when we take an example of the microscope can have optical simple microscope which can have a resolution of around 400x to 1000x, and some of the newly improved optical microscope what we are having, we can go for magnifying up to 3000x we can go for, but the resolution is less for the optical microscope. So if we are having a less resolution, then we can't go for a clear images or the contrast image. So sample what we are having, the resolution should have much resolution here, but optical microscope is having a less resolution, so that the clear images cannot be found out by this optical microscope. That is what we are having. So we are having simple microscope, compound microscope, digital microscope. We are having different type of the microscopes we are having. So what is a working principle? The working principle of this optical microscope, that is image can be captured by normal light sensitive cameras to generate a micrograph. To have an image, we can go for image from an optical microscope can be captured from the optical microscope. We can capture the images by the normal light sensitive cameras to generate a micrograph. We can get the micrograph from this microscope. So the function is to create a magnified image. So the purpose of this optical microscope, it is to create a magnified image of a specimen. Consists of three basic functions of obtaining a clear sharp image. So when we are having a clear sharp images, then we can go for neat pictures here. So sharp images are changing of magnification and bringing to focus. So if we are having the sharp images can be find out by using the magnifying and resolution. So magnifying and resolution plays a very important role in the microscope here. So if we want to get the sharp images, then we have to have a nice magnification, that is more magnification as well as a resolution here. So in this optical microscope we are having eyepiece lenses as well as objective lenses. We are having eye lenses as well as objective lenses and the object. So we are having when we view from the eyepiece, the object what we see it will be the inverted one. We get the inverted images we get, and we see the image here. So it creates a magnified image by combining an objective lens and I'm making an inverted real image. So I have told here the images what we get, it will be of an inverted one. So the above image 1 what we are having, and image 2, the image 1 which will be of the image, it is of a clear image, and image 2 which will be of an inverted image what we get here. So it creates a magnified image by combining an objective lens and making an inverted real image, and magnifies the image furthermore with an eyepiece to allow the user to observe it by naked eyes here. So the image what we see, if it is an inverted one, then we can see the clear images. So the normal, by using only the eyepiece lens, we can't go for magnifying or viewing clearly. So when the rays falls on the sample, and when we get an inverted images or the real images what we get, will have an high magnified, by using high magnified lenses we get a clear image, as well as the space sample what we are going to view will have a clarity, as well as the resolution will be more. With respect to this, we get the clear images. So this is what we are having, the working principle of the optical microscope. It is a simple microscope. By using the eyepiece lens as well as objective lens, we see the images which will be of inverted one, which see as a real images in the we see the real images. So these can be seen, these images can be drawn by using when we connect to the cameras, when we connect with magnifying glasses, we get the images on our computers. We graph images on the computer by this method. So this is what we are having. Micrographs can be generated by using the cameras as well as light sensitive devices. We can draw the graph with respect to this. So then what are the advantages of this? Why we have to use optical microscope? So optical microscope is a simple microscope what we are having. So by the simple microscope, we can't go for an highly magnifying as well as resolution. We can't get that one highly magnification. So when we want to have a simple images or the simple characterization, we can go by using this optical microscope. So when we want to have in detail, we have to go by the other techniques. So this is what we are having. The advantages of the technique. So direct imaging with no need of sample pre-treatment. The only microscopy for real color imaging can be used, this one. So without pre-treatment or without the need of the color, we can go for the clear real color images we can get, as well as fast and adaptable to all kind of sample systems, that is for gas, liquid as well as solid samples can go for the imaging any shapes or geometries. So easy to be integrated with digital cameras. So I have told, to draw the micrograph, we can go for an integration with respect to digital cameras as well as light sensitive devices to store and analyze these data. So the scan, it scans by the method of charge coupled devices. So by using the how the scanning takes place, the scanning takes place by using charge coupled devices. So what to mean by these charge coupled devices, I'll explain in my next session. With respect to that, we are having the scanning electron microscope. There I will explain what to mean by charge coupled devices. Okay, so we are having it is a medium cost what we are having with respect to optical microscope. It is a simple device and it can be operated by any of the persons. We can have a simple operation. It is fast and adaptable to all kind of the environment and the sample systems. So any of the sample systems can for any of the sample system we can use this optical microscope, as well as it is an easy to be integrated with the digital cameras or system data storage systems. For all these we can use. The disadvantage of this optical microscope, which is low resolution. I have already discussed about this one. The optical microscope, we are having a high magnification we are going to have, but we are not having the resolution. So that is what the disadvantage we are having with respect to optical microscope. So low resolution usually down to only submicrons. So submicrons are a few hundred of nanometers. So we will not prefer with respect to nanomaterial. When it is of microns, when we want to have only with respect to microns, we can go by using the optical microscope. But when it comes to the nanometers, or when it is about few nanometers we have talked, but when we are having a nanometer, it is very, very difficult to get the clear image. We get the images, but it is not having too much of clarity due to the resolution. So light diffraction limit. So submicrons are a few hundred of nanometers, mainly due to the light diffraction limit we are having. So decreasing the wavelength is the way to improve the resolution. So wavelength can be decreased to get the resolution. So we can go for finding out with respect to the submicrons level. We can have a usage of this one. So but only thing is we are having low resolution. This low resolution can be improved with respect to submicrons. The clear pictures can be analyzed by decreasing the wavelength to improve the resolution here. So due to this is what the main disadvantage we are having with respect to optical microscope. So in our next session we will discuss about the main part of the characterization technique, the main techniques what we are having with respect to the it may be with respect to polymers, or it may be with respect to nanomaterial, which is the electron based microscopy techniques. So it may be the scanning electron microscope, transmission electron microscope. Like this we are having different techniques which are very, very, very important with respect to this. So right now I have explained about the optical microscope and why we have to go with respect to characterization techniques, what are the use of characterization techniques. So I have explained this one. So watch this one. Be safe, stay in home and be safe. Okay, thank you students.